SOLIDWORKS user groups got their start in 1997, created by users to learn from each other, provide networking opportunities, share their tips and tricks, and more.
The first time I attended a SOLIDWORKS user group meeting was in about 2005. Well, what makes me keep coming back to these is that you're trying to learn new techniques, and there's a lot of minutia and detail that you're not going to learn on your own. So if you can talk to other users, it's very helpful.
The one thing that stands the user group apart, I think, above anything, is the community and the camaraderie and the people involved, and how being involved can get you further professionally and personally.
Being a SOLIDWORKS Users Group member has benefited me professionally. I always enjoy tips and tricks. I've been going to SOLIDWORKS Users Group since '06. I will see one or two every time I go to a presentation that I didn't know existed, or that it's a better way to do something that I've been doing for years. I have met colleagues, which is very important. I've met suppliers, and finally, I've met potential customers for over 10 years at Users Group meetings.
I am honored to be part of this community. I have for years, and if you aren't, you should be part of the SOLIDWORKS User Group Network.
It gives you tips, tricks, and shortcuts you will not find in formal training. It's awesome, and it's free.
It's a fun environment. Everybody gets to know everybody. You get to learn. It's kind of free learning. It's great networking. It allows you to learn from the experts around. I do a lot of presenting as well, so it forces me to learn, so I'm an expert on the topic before I get up there. So all the way around, it lets me be a better SOLIDWORKS user.
To learn more and join the best user community around, visit SWUGN.org and join a SOLIDWORKS user group today.
Welcome everyone to this special on-location episode of SOLIDWORKS Live. Now, instead of feeling wafts of air coming through the vents of an HVAC system at a production studio, we made the quite difficult choice of opting for zephyrs of ocean air. That's right, we are here in Miami for a first of its kind SOLIDWORKS Live show. And while part of me would really love to tell you that you've simply tuned into 1 hour of scenic backdrop for your lunch hour, for your workday today, that's just not what we do here on this program. This episode is about giving you a behind-the-scenes look at two things. One, what it's like to be a Battlebots team with a look at what it means to compete, design, and build bots with an insatiable appetite for destruction. And two, how much fun you can have by getting involved in the SOLIDWORKS community. So when we sat back and thought about it, we realized we have not witnessed much of the magic that happens in our community when we get together in person for the better part of 2 years. And while none of that was planned, I think we can all agree that a bit of fresh air and connection making can stand to do us some good, whether you're a robot or just a regular old human being. So during this episode, we'll first set out by giving you all the insider look at how Battlebots teams Hypershock and Witch Doctor came to be Hypershock and Witch Doctor. These teams, headed by Kyle Allner and Will Bowles on the Hypershock side, and Andrea and Will Galatly on the Witch Doctor side, are quite fortuitously based here in Miami. So this meant we were able to grab a bite to eat with them and head over to their shop to discuss things like, how did you get into making robots? How did you get into Battlebots? How does it feel to work really hard on something only to maybe, just maybe, see it get blown to smithereens? And for those of you at home, what advice would they give someone getting into engineering? And is there a way for you to get involved with Battlebots today? So we'll answer all these questions and more as they explore how SOLIDWORKS has helped and continues to help them accomplish their goals. And speaking of their SOLIDWORKS skills, both teams are giving technical presentations on surface modeling and simulation related to their bot designs at a special SWUGN meeting at the Kubek Center here in Miami. And guess who gets to watch that? You guys, of course, and everyone going to the in-person SOLIDWORKS user group meeting. So it's a great time to get involved in the SOLIDWORKS community. You can learn, you can make new friends, and maybe even meet some TV stars from the Discovery Channel. And as you can see, I am all set to head over to the Kubek Center for those tech presentations. Well, maybe half set. So while I go and get ready for the SWUGN meeting, let's take a look at the conversation we had with those Battlebots teams. Guys, we're live in Miami. The weather is absolutely beautiful. Like, how do you manage to spend so much time in the shop when it's just so amazing outside? Like,
it takes a certain kind of person just want to be working on robots inside when it's 75 and beautiful out.
So it's just sort of a testament to your dedication. Like if you guys were anywhere, if you guys were absolutely anywhere, you think you'd still be working on robots?
Anywhere else can have worse weather, so we have more reason to be inside.
Ah, that's a great point. But I mean, your shop is right around the corner, right?
Yeah, it's like 2 blocks away. You want to go?
Well, I have like a billion other questions for you, but
Come on over.
it's probably better to go over there, right?
Yeah, just come over. We'll show you all the stuff.
All right. You sold me. Let's go.
Let's do it.
All right, we're here on SOLIDWORKS Live. We are obviously not in a production studio. We're at your guys' shop. How's it going, guys?
Going great.
This is amazing. You guys just have like so much capability. I wish you could all be here, all of you watching from home, but why don't you just start by introducing yourselves?
I'm Mike Galately from Team Witch Doctor.
I'm Andrea Galately from Team Witch Doctor.
I'm Will Bales from Team Hypershock.
Kyle Warner from Team Hypershock.
Many of us have been watching Battlebots for seasons upon seasons, and we just have these questions that we would have loved to have asked you guys if we were ever in Miami and if you guys ever invited us to your shop. And we have that here today, so I'm super excited to be able to ask you some of these questions. And of course, we have the bots right in front of us, right? This is super cool. And these bots were designed in SOLIDWORKS, right?
Of course.
What else would you use?
What else would you? What a ring?
Is there something else?
What a ringing endorsement! But I think just to start at like a very human level, how did you guys get into BattleBots? Like that's a question we get a lot. Whenever we talk about like, yeah, we talk to the BattleBots teams. Like I've talked to you guys over the years about just getting SOLIDWORKS and the best stuff to use. But how did you guys get into BattleBots?
That's a pretty long answer, but I'll let you start.
Well, I'll start with how it ties back to SOLIDWORKS. So I actually started using SOLIDWORKS in high school, and we didn't have any SOLIDWORKS class. I just learned to use it because I was trying to build a robot, and it's really hard to build a robot without modeling it first. It's really limiting. So I actually went to an all-girls school, Catholic high school, plaid skirts, knee-high socks, the whole thing, and they had a massive, really well-regarded combat robotics program. So BattleBots used to be BattleBots IQ, which was the collegiate, high school, college. So I got really lucky that I was in a school where it was really easy to get involved, and I haven't stopped doing it since.
Wow. How about you guys?
So the school that she went to, Carrollton, my dad was a first mentor for their first team, even before you were there in the 90s. And so I was growing up around robot competitions, going to first events. Some of those first kids grew up and went on to the BattleBots TV show with robots on Team Loki. So like Ramstein, Turbo, Buddy Lee Don't Play in the Street. And I thought it was the coolest thing ever. So when I was old enough to do it, my friends and I, Tyler and Benji Pantoja and I built our very first robot. It was a 14-inch walk bought from Kmart, upside down, covered in black and white duct tape to make it look like a cow, and we called it Heiferbot.
Heiferbot.
And it spun around, and it was our first robot, a full-body spinner, shell spinner, kind of like Gigabyte. And it was not good, but I was hooked.
Yeah. That's really interesting. I mean, like you mentioned, FIRST Robotics. Like there's a lot of people, I'm sure, even in the chat that have experience with FIRST. So it's kind of interesting to see that, our beginnings can converge and then go out in many, many different directions. So it's interesting to hear how you guys landed where you landed today. Speaking of, another question I get a lot, regarding you guys is what is it like to, be building these bots that eventually end up on the Discovery Channel? like what is that like? Maybe even the first season. Like what was it like when you first got on? How did that feel?
Honestly, it was like a dream come true. Like Will and Andrea, when I was a kid, I used to watch BattleBots on TV. And then when I got into college, we found out about this robotics club, and I went to check it out, and it was these fighting robots. And started in 2000-something, 5-ish, and kept doing it, and I've been doing it ever since. So, when the BattleBots TV show came back on in 2015, it was a dream. We were like super excited to be doing it with all the people that we watched when we were growing up. And, we wanted to make something really creative and really unique looking. And so we submitted Witch Doctor and had this like skeleton and bones theme, and just wanted to make it a really cool aesthetic.
Yeah, how about you guys?
So I didn't get Kyle the first couple of seasons because he was still trying to going through college. I dropped out. I gave up. He was much more diligent than I was.
First of all, I don't understand it. Like, just to be clear, you guys have full-time jobs like that.
Yeah.
And so this isn't like that's probably a super. I'm sure you guys get this a lot. Like, it's a super common misconception.
Yeah, this is a very expensive, time-consuming hobby that we do after work. Normal, full-time jobs. So it's a passion project. It's what we do for fun. But Kyle and we started doing this in high school together. We were building little robots. And when Greg and Trey, the executive producers of the show, said, hey, we're going to have a new show again. You want to build? And we're like, heck yes, of course we do. And so we built the first Hypershock. It wasn't nearly as pretty as this one. I definitely like this one much more.
What's your naming convention? Is a really funny thing. Like, is this Hypershock V17? Like, I love you, V17. Like how do you or do you just go Hypershock? Like, how do you talk about the different iterations of your bots?
Every season we forget about the previous one. It's just totally retired. This is, right now for us, this is Witch Doctor, and there is no other Witch Doctor.
Speaking of, another thing I've been really curious about is, what is it like to put so much energy, Will, like you mentioned, like you put a ton of time into this. You call it an expensive hobby. But what is it like to put so much work in these bots and then maybe have them get destroyed, obliterated? Yeah, 100%. Like, what is? I've always wondered, like, what goes through your heads. Like, do you mentally prepare yourselves before competitions, just thinking, hey, this could happen, and you're just ready for it. Like, how does that feel?
Well, every time it gets destroyed, it's not just a matter of fixing it how it was. If it got destroyed, there's something we can improve on. So it's also an opportunity to build it differently. Like, we teach classes for kids to start building like little combat robots like this. And the biggest hurdle is getting them to not be afraid of breaking it. And that only comes once they know and they're confident that they can fix it. Once they know they can fix it, they don't care what happens in there. They're having fun.
Sure.
And obviously, we're confident we can fix it, but every time it breaks, we fix it, in a new way that's going to be better. And this year specifically, we did that a lot, just like in between matches.
Mm-hmm. How about you guys? Like, what is that, just even psychologically?
So we have a bit of a reputation for bringing things right up until the last minute. We're building right up, at filming. We're building the robot for the first time at filming. So I think it's a bit of catharsis to watch it get destroyed. Like, oh, finally, like, okay. And then, but it's funny though, because if one of these fell off the cart right now, all of us would be terrified, like, oh no, we broke something. Meanwhile, Hydra will throw you 15 feet in the air and you're like, yeah, whatever, it's fine. They are definitely like in a lot of ways, there are children. There are creations that we're, ripping out of our heads and through SolidWorks making into real stuff, and then we send them out to kill each other, and it's a lot of fun. That's the good news. It's a lot of fun, and it doesn't seem to bother me at all that they get destroyed.
Nope. That's the name of the game, really. We don't just show up with one robot. We show up with 2 or 3 robots, plus extra spares. Parts like the armor or the wheels, things that are going to get damaged every fight. We bring 4 or 5 sets of those, sometimes 10 sets. How many wheels did you guys bring?
We went through, we brought 16 wheels and we made 16 more while we were there. So we were losing wheels left and right.
I guess it's a good point, Mike. Like, it is after all, it is Battlebots. Like, you should expect this to some degree. Like, it's kind of what you sign up for. And speak.
The battle scars too they're like a badge of honor. Like this part here fought Endgame, who won last season. This part here, you can see all this damage right here. This is a tantrum punch. It's very distinctive. Who won this season? So it's
like a signature.
Yeah.
Yeah, let's just take a look at that. I mean, that is interesting, sort of how you think about it. And it's so funny when you think about SolidWorks, right? Like, everything's perfect in CAD. And then all of a sudden, we get here, and it's like you look at these scars as sort of badges of honor, right? It proves that, hey, they fought, they lived, this is great. No, I think that's super interesting. In terms of, you guys are going to be presenting at a SWUGN meeting, right, tomorrow. Talk me through some of like the design considerations, like even for example on Witch Doctor. Like, is this all done using surfacing tools? Like,
yep.
Kind of what am I looking at here?
Yeah, so this rib armor is all 1/4-inch aluminum. We have a few different configurations of this actually, but this is done with a combination of surfacing and sheet metal tools. But the main consideration for all these robots is they all have to be under 250 pounds. So we use mass properties. We assign masses and materials to certain components to every component in our assemblies. Because you have to know. Right. And you don't want to show up at 255 pounds because it's really hard to remove that weight. You have to start cutting parts or removing parts altogether because there really is not a lot of areas you can cut out that don't compromise something else. So when we design the robots, we're really trying to get as close to that 250-pound mark as possible in CAD, while accounting for weld weights, hardware weights, and all these other minor variables and material thicknesses and things like that. So we have big spreadsheets that we're tracking weights and different configurations. I'm sure you guys do the same thing.
Same thing. I was opening the assembly for this yesterday. It's 888 parts because I have every screw, everything's in there, and because you need it. There's 10, 15 pounds of screws in this thing. And like Mike said, if you show up and you didn't account for that, well, guess what? Now you can't have your pretty armor, or now you can't use the strong armor configuration that you were hoping to be able to have. And then you have to start making compromises, and it's not what you wanted. And yeah, it's sad and it's frustrating, and it makes another challenge that you just don't need if you can avoid it.
Yeah, it's so funny. You think about like fighters, going into the ring, trying to make weight, right?
Yeah, imagine if JSP had to go in there and cut his hand off. You're like, oh, rats! I'm overweight.
What would you guys say? We've talked about kind of our beginnings, right? What would you guys say to any sort of designer, engineer, looking to get into BattleBots today? At the very beginning of this talk, we talked about how you guys got into BattleBots in the first place, how it felt, season 1. What would you say to engineers, designers today looking to do the same?
Make one. Just make one. It doesn't need to be big like this. The smaller 1 pound, 3 pound robots, they're much more accessible. They're much easier to make. You can 3D print basically all the parts, or you can use hand tools and stuff that you get at the hardware store. There's lots of little events all over the country, so it's much more accessible in terms of the competitions. And then from there, your robot addiction can grow and flourish.
Yeah, it's interesting, Andrea. You mentioned using SOLIDWORKS in school. It's interesting. I think about today, some of the offerings that we have. We have an offering just for makers. It's like $9.99 a month. What do you guys think? And this is kind of a trend in software overall, right? We're trying to make it more and more accessible. Like, how does that make you feel about the future of robotics?
Well, I know, at least for me, knowing how to use SOLIDWORKS well was a huge factor in getting my first job. Because you don't come out of high school knowing how to use SOLIDWORKS, right? Like, CAD programs aren't really used in high school. So I got an internship, early in college, and I was way ahead because I was doing assemblies and sheet metal parts because I had to. It was fun, and I was trying to get to a goal. But when you come in as a, 18, 19-year-old to a job interview and you have those skills because you've been building robots, it blows them out of the water. So it had a huge, huge impact on my career path.
Awesome. How about the rest of you guys?
Same. Yeah, building robots, I think I was 14 when I got taught by the guy who's my boss right now, actually. Yeah, I was a summer intern, brat kid, and
brat kid.
they did some special thing for the robot kids, and I designed my first robot and learned all about sourcing parts overseas, staying up all night talking to machine shops in China, and that was a wonderful experience. And also,
that's a crazy level of experience. So you're saying as a teenager?
Yeah, too much freedom to to learn things the hard way. And it's stuff that I'm doing now, and it's stuff that all of us are doing now in our everyday lives and jobs is come out of what we learned doing robots and playing with SOLIDWORKS, and it's fun.
Awesome. Cool. Well, thank you guys so much. I'm excited just to dig through all this stuff. We could probably spend a full day worth of streaming, just looking through the crazy mix of capabilities that you guys have here. But again, thank you for welcoming us here in Miami. Appreciate it.
Awesome.
Thanks for coming.
Thanks for coming.
All right. Thanks, guys.
Hi, viewers. My name's Will Bales from Team Hypershock.
I'm Andrea, and this is Micah Lately from Team Witch Doctor.
And we're here to talk to you all about how we're building robots with SOLIDWORKS, and all the little nitty-gritty tricks and crimes that we're committing while we're trying to design these things. So you guys want to go first?
Yep, we'll get started.
All right.
So like I said, we are Team Witch Doctor. I'm actually really excited about this presentation because usually our audience is not a technical engineering type audience, so we get to talk about all the things that get us really, really excited about designing these robots that we normally don't get to talk about with our general audience or younger audiences. So I'd like to start by thanking SOLIDWORKS for sponsoring Battlebots, sponsoring our teams, and supporting the sport as a whole. I think the most difficult thing about sponsorship is that they have to trust us and give us resources and money before there's a robot. There's not even a plan for the robot. They're at the very, very early stages. So there's a lot of trust in us to come up with something cool and deliver a competitive robot. So thank you so much to SOLIDWORKS for making that happen for us. So if you've seen the show, then you know that our team is best known for competing in skeleton jackets and top hats. We're a very colorful team. Right there at the bottom of the screen and here in front of you, you see Witch Doctor. We put a lot of effort to make a very competitive robot that also looks really cool aesthetically. So it's a really, really fun challenge, and all of the features in SOLIDWORKS really help us make that happen. So I'll give you a little bit of overview on Witch Doctor. We have been in all 6 seasons of Battlebots, just like Hypershock has. I think we're only one of a handful of robots that has competed in every season of Battlebots so far, since 2015. Spoiler alert, cover your ears if you haven't seen the season finale, but we are coming off a finals run on the 2021 season of Battlebots, so this is our second finals run with Witch Doctor, and we have some other awards that you can see there. If you're not familiar with Witch Doctor, we are a dual disc skull weapon vertical spinner. Our weapon is designed to tear through opponents while launching them up in the air. If you saw some of the footage earlier, or you've seen the show, you know that already. We have a 200-mile-an-hour weapon tip speed. The maximum on Battlebots is 250 miles an hour, so we're not pushing that limit. We are a smaller diameter weapon than some of the big horizontals, which are really pushing that limit. And as you design to hit harder, you're also taking a lot of that shock, so we're kind of inching our way up to that speed tip limit. Witch Doctor is constructed out of a lot of different materials, and we'll talk more about the technical aspects of that. We have our front armor and our back armor is all steel, AR-500 steel, which is used in construction equipment. Our rib armor on the top, which is probably one of our most iconic parts of Witch Doctor, at least visually, that's all aluminum, and we actually have different thicknesses depending on who we're fighting and how we want to shift our weight around. And then we also have titanium armor that a lot of people don't know because it's actually hidden underneath our ribs. So if an opponent is able to rip one of our ribs off, then we still have titanium underneath that to protect our insides. And one of the features, one of my favorite features about our robot is our custom molded wheels. We had a season in 2018 where we had a recurring issues where our wheels just kept falling off the robot from hits that really shouldn't make that happen. And it was a really big focus of that season to redesign our wheels. And I'm really proud that since that, for all of 2019, 2020, and 2021, we haven't lost a single wheel after that. And a really fun fact about them is that they have a custom designed bone tread, so they're totally on theme. I don't think you could see it on TV. I don't think they've zoomed in on it, but you can go ahead and see it here in person if you have a chance after to see that really cool bone tread that gives us some extra grip and really makes it look like a Witch Doctor part. So we designed a 5-part mold that we 3D printed in order to make that possible. So let's talk about using SOLIDWORKS. So I am going to talk kind of a higher level approach to how we use SOLIDWORKS. I'm expecting that these are a lot of features that everybody in the room already knows how to use, and I'll just talk to how we apply them to making Witch Doctor possible. So we're going to go through mass properties, which I know is a dialogue that a lot of people use. It's probably one of the simplest features in SOLIDWORKS, but because of the weight limits and our weapon design, it becomes really, really important for our design process. We talked about how we really want to make Witch Doctor aesthetically pleasing and a really cool design and not just a really simple box. And our formed sheet metal parts really play a big role in that. If you look at Witch Doctor, a lot of the parts you can see are formed and help give it its unique shape. So we're going to talk a little bit about the complexities in making that happen. If you watch the season finale, you'll see that for our last 2 matches, we actually debuted a new configuration with a single disc. And we actually had to design that to be within the same weight and work with a lot of the same frame that we had. So we used configurations in SOLIDWORKS to make that happen. And because of that weight limit, we actually got to use a feature that I believe is pretty new to SOLIDWORKS, which is topology optimization, to really tweak some of those designs. And finally, we'll show you some of the process of actually building Witch Doctor and getting it ready for battle. All right, so let's jump right into it. So the weight limit on Battlebots is 250 pounds, for those that don't know. So when you see these robots flying through the air, try to imagine how much energy it takes to throw a 250-pound robot of this size 16 feet in the air. And imagine what you have to do to survive landing that and survive being the one to toss a robot up that high. So there's some really, really significant forces involved. This is Witch Doctor this season on the official Battlebot scale at 250 exactly. So you don't want to compete underweight at all, because when they're throwing you, that's just an advantage for them. So we try to keep it as close to the limit as we possibly can. So here in the mass properties dialog, you'll see that the robot on CAD is designed for about 239 pounds. Our goal was 240, so we have a little leeway. And that's because there's a lot of weight in wiring, mostly in electronics, that we don't include. We haven't gotten to doing all our wire routing in SOLIDWORKS yet, maybe in the future, but for now we estimate that. So we kind of give ourselves a little grace there. And then underneath you can see all of the custom components that we have, which are our speed controllers, our batteries, our motors, all the parts that we model to match the actual physical parts and bring into SOLIDWORKS so that we can design the mating parts and estimate the weight. So all of those parts actually have overridden mass properties so that they have as close to actual weight as possible. So we don't trust the motor weight from, we use mag motors, we don't trust it from their website. We actually take one and weigh it and make sure it's as exact as possible. Because when you have an assembly of hundreds of parts, every ounce is going to add up to getting you overweight. And if you're overweight at the event, then you have to start cutting weight from places you don't want to start cutting weight from. And then the other thing we really use a lot on mass properties is center of mass. Here I'm going to talk specifically to the weapon, but before I get to that, center of mass on the robot assembly as a whole is also really important. You'll see that the heaviest part of our robot is this big steel weapon right at the front. But we're four-wheel drive, so we actually want the center of mass for the entire robot to be centered on the center of the wheelbase as closely as possible. We don't want the robot to be tipping or trying to pop wheelies if that's wrong. So that really lets us move the motor placement and move our internals around to be able to really balance the robot and drive really well, which was a big focus of our season this year. Something that's not unique to our weapon, but a really big part of what makes our weapon so effective is that we have a single hitting tooth. We don't have a second tooth on the other side that balances it out. And in order to do that, we rely really heavily on the center of mass features in SOLIDWORKS. We also have this really cool skull shape on our weapon, which you can imagine, we're not going to take out some paper and try to figure out center of mass with geometry. It's not going to work out. So we really do that dynamically within SOLIDWORKS. And we kind of tweak to optimize the shape so that it's also the lightest weapon assembly that we can make while still making it strong enough. So optimizing that is really, really important. Here you can see the exact mass on our weapon assembly. It's 408.4 pounds. So that's the entire spinning mass. That includes our bearings, our hub, all of the hardware, and from the center of mass, like I said. And another really critical thing in this dialogue is a moment of inertia. So by using the moment of inertia without having to calculate it on this complex assembly, we can actually estimate how high the energy is that we're going to be delivering to our opponent. That way we can figure out how thick we need to design parts for our own robot and obviously optimize the energy of the weapon. You'll notice that it's not just a simple bar, and that's because the further out you have the weight on the weapon, the higher your moment of inertia is. So it helps us maintain the weapon spin up and hit a little bit harder.
Hello, I'm Mike. So I'm going to talk about some of the other design features of SOLIDWORKS that we use to design Witch Doctor. You know, like Andrea said, like every team kind of has their own workflow. A lot of teams have their, multiple sponsors that help bring these robots to life. So a lot of teams design kind of around what type of manufacturing processes they have. So Will spoke before about designing a lot of things for laser cut sheet metal and welded weldments. And we have a water jet sponsor, so we do a lot of like aluminum water jetting. So it kind of really depends on like what processes you have at your fingertips, and who's willing to support that. Obviously, a lot of people pay for stuff. A lot of people go out for sponsorship. So there's really a wide range, and there's 60-something teams, I think, this season, maybe more. So, you know, when you look at other robots on the show, you can kind of see, if you think about like the manufacturing processes involved in making these robots, you can kind of see, you know, some teams have access to their own CNCs at their own shops or whatever. So see a lot of billet parts on those types of robots. So we use a lot of sheet metal parts for the armor, as Andrea mentioned, and we have a lot of multiple configurations of said armor, which we also track in SolidWorks as well. So you can see here on this image, this is basically like right when we got parts from the WaterJet, our WaterJet sponsor, who also does the forming. And you see the still raw aluminum armor here. And this is like the first time we've like really put the robot together, just to make sure that, you know, these holes line up, right? You're talking about, you know, you can see the holes on the flat pattern are like on multiple planes and stuff. So this is like the sanity check, like we put it on for the first time and we go, oh, whew, sigh of relief, you know, everything kind of lines up. So here you'll see the rear armor that the wrench is kind of still on. That's a 1/4-inch titanium. Like Andrea mentioned, we have titanium armor and steel armor and a few different configurations. So that's actually the titanium. Then the silver stuff is all aluminum. So at any point, and obviously like when we first started building these Battlebots in season 1, there wasn't that many teams and there wasn't that many robots, and you didn't get that many fights in each season, even if you won. You know, it was like you get into the tournament and then if you lose, you're out. So you get a couple of fights maybe. So you didn't have to show up with a ton of spare parts. But now the show has evolved. Everybody, as you guys watch the show, you know that there's these fight card fights that are basically like a seeding round before you go into the tournament. So you're going to have 2 or 3 fight card fights. So you have 2 or 3 fights guaranteed, and you might get destroyed in 2 or 3 of those fights. So you have to have enough spare parts to, you know, repair the robot before you even get into the tournament. And then obviously your tournament fights are against other seeded robots. So you know, you have to plan for taking a lot of damage. So your robot has to be repairable, and you have to show up with, you know, multiple sets of parts. And you don't know who you're going to fight ahead of time. So there's 60-something robots, and a lot of them are different types of robots: lifters, grabbers, horizontal spinners, et cetera, et cetera. So, you know, you have to have all these different armor configurations for different robots, and now, you know, things like that. So here's some of our sheet metal parts. So, you know, in SolidWorks, obviously we do all of our manufacturing drawings, and as you guys all use SolidWorks, so you know that like the sheet metal features are really great and super easy to just like click a face, export DXF, and you can get your DXFs out and saved out for WaterJet or whatever your secondary processes are. And then we create bend drawings, because obviously those 2D parts will go to a forming process. So we have bend drawings, and we actually create some of these bend gauges that are basically just a 2D template that we can quickly check. That's for the manufacturing guy to check. But, you know, as you saw on the previous slide, the parts actually line up, surprisingly, so awesome. So a little bit about the configuration. So as you see on the left side, so the way I model my Witch Doctor is like the frame is a multi-body single part, but then like all the other parts, there's a lot of parts with multi-body parts and sub-assemblies and stuff. But so when we do configurations for the robot, the front armor, the top armor, you know, and this weapon assembly that you'll see here, on the left is a dual disc configuration, which is what you see up here. And on the right, for the first time this season, we had this single disc configuration, which is kind of like Hypershock here. So in order to achieve that configuration without changing out like the whole frame, because you don't want to, you want to minimize your time between matches. If you have like a quick match and you need to switch to the other configuration because your opponent might, you know, have a specific weapon type that you want to use a single disc for, you know, it's a thicker slab of material, so it's a lot stronger, maybe for horizontal spinners or whatever. So anyway, these configurations, obviously we use mate configurations. The frame, all the purple stuff is all is a part file with a multi-body part, so that has its own configuration, configuration matrix is pretty crazy. But, you know, this helps us keep track of weights and, you know, make sure that we can quickly check, you know, interferences and clearances for hardware and all of that. And like Andrea said, you know, this is 250 pounds hard limit. They don't give you any room to budge, and there's even some, you know, one scale might be a little bit more sensitive than another scale because they do have 2 scales. So you really have to be, you can't be 250.1. You have to be 250 and then maybe even a smidge less just to make sure, because the wind's blowing one way or the other, you know. So as you see on the left, this is our dual disc configuration, and we have a lot of parts that basically are suppressed for the single disc configuration, and you know, just helps us keep track of everything sanely. So one thing that we use on this is an internal component in our frame, is a topology optimization. We use this in 2020. We started using this in 2020. So in the top image, you'll see that's basically like the internal frame member where our self-righting mechanism mounts, and those 2 holes are basically the 2 axles where those mount. So we got a hold of this topology optimization, and we basically ran, you know, a lot of people ask, do you do any FEA or anything like that with these BattleBots? And, you know, the short answer is that the amount of force that other robots apply to your robot, you can't even like fathom like how much force is required, like you said, like to throw a 250-pound robot. So you're basically testing, if you do FEA, you're basically testing everything to failure. So I'm pretty like conservative when it comes to make wall thicknesses and stuff like that. But when we did this topology optimization, we wound up calculating. So you can see on the top right image, that's our self-righter kind of up at an angle. We calculated how much force it would require, you know, to self-right the 250 pounds back over, because that's pretty straightforward. You know, there's another robot's not hitting you or whatever. So it's a very easy calculation to figure out the moments required and the chain tension required to get the robot back over. So we're able to do this topology optimization pretty safely, and we wound up able to go. Can you go back one slide? Thanks. To like reduce, the original design wasn't a solid body quite like that, but it did have some weight holes removed. But you know, we were able to kind of skeletonize that part a bit while running this topology optimization, and be confident that it was going to give us something that wouldn't fail. But I don't know if anybody's used topology optimization here. Hands? No? Hands? Yeah, cool. So as you know, it gives you this like mesh body that's not really manufacturable necessarily. And our workflow was to have these parts water jetted. So we had to basically stick to a 2D profile. So the bottom left image is what the topology optimization output. And you know, we basically took that body and created a sketch that kind of roughly estimated it to get the you know, clean body on the right side. So and that's the only place, unfortunately, that we've used topology optimization. Actually, well, the one on the right there, so the one on the left is from 2020, and the version on the right is from 2021, the robot that's here. So we did wind up changing it a little bit. You can see this strut on the top doesn't really take any load in at least the loading scenario that we applied to it. So we were able to actually cut that off and save us some weight and some space inside the robot. So yeah. So hopefully we'll get to use that more, you know, if we get more familiar and more comfortable, you know, doing that. Do you want to jump in, or do you want me to? Okay.
So now comes the fun part. The design's the fun part too, but it's really fun to start actually building the robot. So here you can see all of the parts. This is from Kalamazoo Water Jet that does all our water jet cutting. So you can see kind of, if you look closely, you have some of the ribs that haven't been formed yet. You have our weapon assemblies, a bunch of our frame rails. So we basically got a flat pack version of our robot. Then we take everything to anodizing. So it's that really bright purple. This is the first year we've anodized our frame instead of painting it, and we were really, really happy with that. It held up a lot better. So then we get to start putting the parts together. So here in the first picture, you can see we're starting to test parts. Now we rely on SOLIDWORKS a lot, because by the time we get to this part that we're actually test fitting parts, we don't have time to go do a whole other iteration, so things have to fit. Obviously, we can make small tweaks. We do have some machining capability, but we really, really need the parts to fit. And then Mastercam does all our CNC machining, so you can see the silver parts there are all CNC machined and everything's starting to come together. And then on the second picture, you can see your entire team starting to jump in and really adding the guts to the robot and the wiring and the chains and everything that makes it run. Yeah, you can see Hypershock in the back, so that's how closely we actually work together during the build season. There's no secrets between the two teams. And then finally, the most fun part of all is to actually put them in the battle box and fight some robots. We like to joke among all the teams, because the teams are friends, that we get together once a year and break each other's toys. Because we spend, all year trying to figure out how to build them, design them, put them together, and then the first thing we do is slam them into each other. But this first picture is against last year's champ Endgame, which is another vertical spinner, so there were a lot of weapon-to-weapon hits. I'd say pretty much the whole match looked as sparky as this picture here. And then the second photo is against Saw Blaze, which is a super destructive overhead spinner, which actually inspired a lot of the rib look on Witch Doctor because of the direction that they actually hit you. And this was a semifinals match from this season. All right, so that's it for Witch Doctor. We're going to switch over to Team Hypershock and let them talk about how they use SOLIDWORKS to design Hypershock.
All righty. Okay. So Mike and Andrea did a great job of giving you a really good overview of what goes into building a robot, what goes into designing a whole robot. We're going to talk about the armor. Next slide. So Hypershock, like Witch Doctor, we prioritize the aesthetics of the robot. We want it to look cool, right? It's a passion project for us, so by golly, it's going to look good. So at this point, here's your scenario. We have all our machine parts ordered. I've already designed all the CNC parts because they're longer lead time. I've sent them out. They're getting made. So the weapons, the wheel hubs, all the bits are there. And I have this Oort cloud of floating components in an assembly. Now, unfortunately, robots don't stay together like that in the arena, so you have to stick them together with stuff. It's August 4th in this scenario. Totally hypothetical, definitely didn't do this in real life. Battlebots is filming on the 20th, and I have no chassis and I have no armor. So I have 16 days to design the sheet metal chassis and the armor and build it. Welcome to Team Hypershock. So some context. We have a history of showing up and building the robot at filming. For better or for worse, I am the king of procrastination, and it's almost become expected at this point. For the armor itself, this is one of those rare examples of function following form. Truth be told, underneath the armor that we're going to design today, there's some more armor. When you come up here and see it, if you're here in person, there's a 1/4-inch titanium plate underneath this. We don't really need this cool stuff on top, but it's cool, and I want it. So guess what we're building? Because, like it says here, it's a TV show. Entertainment is of utmost priority for us, and that's what makes it fun. So here's our armor design prompt. It needs to fit around the internal components and the chassis that I've yet to design. That's another fun one. And what I'm actually going to do here is I'm going to take my Oort cloud of parts, and I'm going to design the armor around it, and then I'll make the chassis attach the two things. So I'm doing this inside out, outside in approach, because I'm a crazy person. I need to make it manufacturable because I have only finite resources. We are sponsored by Senkatsen. They have great laser cutting services for sheet metal, so guess what we're making it out of? We need to consider the limitations of bending titanium in AR500 because what we wanted to do is we wanted to have an aluminum, a steel, and a titanium version of our armor that all look the same. We want no one to know which configuration we have. So if we're going up against a hammer, maybe we'll go with the thicker stuff. If we're going up against a spinner that's going to hit the sides, the top's not going to get any damage. Put the light aluminum on top. But we don't want people to find out. It actually... There are some things that turns out Witch Doctor didn't actually know until a couple weeks ago, so that was fun. We need to hide some crimes. So try as I might, You can't make everything non-rectilinear. All the batteries keep coming in square shapes. All the motors want to get mounted perpendicular to other things. Chains don't go around bends. So I'm going to use the shape of the armor to try to hide some of the more boxy parts of the robot. And we need to not interfere with core robot functions or invertibility. So we got rid of the self-righting mechanism here, which has been quite the controversy for some fans. But in order to, the self-righting mechanism was like 30 pounds of stuff, and we figured 30 pounds of stuff is probably better serviced in armor and weapon power. So that's what we did. But that means when it's upside down, the armor can't be in the way. If the pretty stupid armor gets in your way and you can't function, then it kind of defeats the purpose. We need to avoid right angles at all costs because, like I said, I'm a crazy person, and our designer and I, we have a designer on the team, Isaac Labarsky, and he's responsible for the graphics and the aesthetic of the robot, and so he and I are going to go back and forth in this process, and we like non-boxy things, and you can't hide your crimes with more crimes, so no right angles. And ultimately, we need to make the coolest looking robot armor in Battlebots because we want a toy. The best thing you can do as a Battlebots builder is get a toy. They have 2. So I just want 1. So I need to make it look cool. So here's our workflow. Isaac is a graphic designer. He's not used to CAD. So what he is comfortable with is paper, Illustrator, and I got him to get into Blender. So here's this back and forth workflow that we go through. I'm in SolidWorks, and I give him this rough assembly of where parts need to be. And then he brings it in and he starts drawing on it. And we'll print things out and start drawing on pieces of paper, and the desk is covered in paper and it's a total mess, but it's starting to work. And so we get to the point where we have some approximate ideas of what we want this thing to look like. It's not perfect. There are some intersecting parts. There are things that can't be manufactured. Sorry, Isaac, that's a compound curve and I can't make it with a 2D bend. And so there are some compromises that I need to start to consider when going into SolidWorks for real. So I take Isaac's screenshots and I set them up on reference planes in reference sketches, and then we get to work. So I'm going to walk you through it. Okay. All right, so we have our 3 reference sketches, right? And so I have the top views, and this looks pretty neat, but you can probably tell like here, for example, it starts to fall apart. And you can see from the side, this is last year's side armor. It doesn't work, but we want something as a placeholder. So we're thinking as we're going. Remember, we have 16 days to make this thing, so we're working fast. Like I said, we need to be invertible. So I draw a line between these horns over here that keep the weapon off the ground when it's upside down. It's supposed to do that. Yes, I know everyone in the YouTube comments is saying, oh, that didn't work. Well, they were supposed to work. I'm sorry that 3/16 thick titanium was insufficient. So we have this here, and I have a reference line of where I think the top of this louver panel thing is going to be, and still give us like 1.25 inches of ground clearance when we're upside down. So this is where things get messy. And I apologize to all the SolidWorks purists out there, because you're going to see some things that you're not going to like. I contend that there may be a right way, but there's no wrong way as long as the model looks right at the end. All right, so I need to make a plane. And what I do is I make a plane right here that I'm going to start a sketch on. And then I start projecting curves. So what I did is I went in here, and I made this ugly drawing of what I think is going to be a shape that I can make that will fit around the other components in the robot, and works with the angles and other design ethos that we've been going with. We would do a lot of 30 and 60 degree angles, very consistent geometry. It helps when it's 3 in the morning and I don't know what angles it should be. So I have this shape, and what I do is I'm going to project it onto this curve, onto this plane rather. So I have this curve projected on this plane, and then I need some bend lines. Now this is taking a swag at where I think I'm going to bend, because I don't have I'm not doing this within an assembly. I'm taking a stab at where I think the components will need to be and where I think I need to have space and geometry. So I put some bend lines in a sketch here, and I also project that onto that plane. And then I convert some entities, and I make the first facet of my what are we going to call this? Armor panel. And I start rinsing and repeating. So I do that one. And then I make a plane at an angle. I put it at 40 degrees, and I do the same. I make another one. And what I'm doing here is I'm projecting these curves on these planes, and again, doing all sorts of terrible things to the SOLIDWORKS gods. I'm sorry. But I'm starting to make a shape. Again, 3 in the morning, 4 in the morning, probably on the 5th. And then I do it again. And I'm starting to make this shape. So when you look at it, we're deviating from Isaac's original design, but he and I were talking back and forth, and we're figuring out what's going to work. And keep doing it. And now I have more or less a shape that I think will work. And I knit it, and then I turn it into sheet metal, and I convert it to a solid. And mirror it. And so now I have more or less a thing I could imagine making, which is good. None of my bends are going to mean you have to have some crazy thing. I'm looking at, thinking back to experience in the past. We work with a local bender for the local people. It's right behind the Big Cheese. It's great. You can get pizza and bend metal. And I know they have a 2-inch diameter die, and they're comfortable bending AR 500 steel and titanium in this kind of gauge. So, and I can get away with about 40 degrees, and that's about it. So I'm feeling good about this. And then I start going through, and I'm making it pretty. I'm putting fillets on and making myself feel good and feeling less lost and hopeless at 4 in the morning. And then I start doing it again for the next panel, and I'm doing this trick where I'm converting entities and projecting curves and making more facets. And lo and behold, we finally start getting something that looks like some armor. Starts to look representative of something. And at this point, I'm, again, feeling better. And so Isaac and I will start going back and forth. And we have this, and we'll start doing all the other little panels, and we'll do the side armor, and we'll do the front armor. And in the meantime, I'm starting to figure out, where a mounting point's going to be. What kind of weight can we get away with as everything's starting to go together? All the things that Witch Doctor talked about managing weight and optimizing shapes and stuff, I have to do in real time in a time crunch because I'm a terrible person. So, all told, we went from Rev 2 at 3:05 in the morning, 3:05, on August 5th, to Rev 10 days later at 11:52. And you'll look at this calendar, you'll notice that 11:52 p.m. on the 15th was the night before. 11:52 on the 15th is the night before we can send it to our sponsor and beg them to make these parts overnight. So we send all the parts over, and I've also done the chassis, which we haven't gone into. That's a story for another day. So we send all the parts to Senkatsen. They start making them. They start questioning whether we're sane or not, and we're actually going to make this in time. We did get notice from another builder who works there, like, should we actually make their parts? And they're like, yes, please make their parts. They'll figure it out. Thank goodness. Thank you, Shay. So we go from the 16th and the 17th, they're making it. They ship it overnight at great expense. Turns out that shipping hundreds of pounds in metal, it costs about $3,000 from Nevada. Sponsors, everybody, sponsors. So now we're on the 18th. We get all the sheet metal in person, and you can see here, I was very happy with all the sheet metal. And we get all the sheet metal out. I start welding. The rest of the team starts marking all the bends because we don't have time to go, give fancy drawings. I'm sorry, witch doctor, we're just not as prepared as you. So I don't have fancy drawings. So we're manually marking on all the sheet metal where the bend line needs to be and approximately what angle it needs to be at. The next day, on the 19th, at 6 a.m., after no sleep, I show up at the bender, and then we tag team between my brother, my mom, I think Kyle, did you go? Okay, Kyle got out of it. And we spend 6 hours nonstop sitting there with the bender just handing him parts. And so I think we bent 36, 40 parts that day, and then they went straight to the powder coater. So you'll notice that the yellow oval goes across 2 days. Remember, Battlebots filming starts on the 20th, and we're making the armor and welding the chassis for the first time on the 19th. Half the team goes to filming on the morning of the 20th, with some of the powder-coated parts done. The rest of the team stays behind, goes to, what was his name? Carlos, my hero, who is powder coating all these parts in record time. They go to him, they go straight to the airport with bags full of these bright yellow powder coated parts, and we assemble the robot for the first time at filming, and it works. Somehow. So you can see our bounty of all our parts. You can see like this here is that part, that first top part that we made. And then over on the other side of the screen, you can see it all bent. And then the final product with SolidWorks. Yeah, there you go. That's how you make a robot in 10 days.
All right, one more time. Everybody at home, everybody here, let's give a big thanks to those two presentations. That was awesome. I have to say, too, two very different approaches, right? I mean, I think that's one thing that's probably obvious to everybody here. It's so interesting, different paths, different methodologies, right? And you end up with different sleep schedules, yeah. All right, so we're going to transition towards the tail end of our event here into the live Q&A. So we're, of course, going to take questions from the audience. We're going to relay questions up here. We'll repeat them and get the team members here to answer them. But we also want to hear questions from home. So if you're listening at home or wherever you are, please let us know. We got some great folks monitoring the chat, and we're going to relay some questions. So anybody here? Anybody want to start with a question here? Right here, sir.
You're assuming there's a lot left after we go to Battlebots. This robot that's here has actually been repaired. If you saw the season, we ended up with our single disc configuration. We're back to our double disc configuration. Most of the parts on this robot we would not compete with again. They're not usable. So we use it for show and tell. We have the 2020 Witch Doctor. We donated it to the South Florida Museum of Science, and it sits there so kids can come and see it in person. And we use this one when the team travels. But we traditionally do not have a lot left at the end of the season. Whether we do well or not, the damage is just a lot.
We're usually at the season 2 at that point. Some teams, so these robots are a little too dangerous to go compete at some of the other events. Robots like Kraken and another Florida SolidWorks team, they have a crusher. And so they can go to some of these other events and still have a good time. So maybe we should split it.
Oh, yeah. We'll need you to repeat what you just said.
So just repeating what I said, we also run out of steam. At the end of the season, we're whipped. We're totally tired. We don't want to do any robot stuff. But there are some other teams who have robots that aren't quite so dangerous, like Kraken, another Florida SOLIDWORKS team. And they have a crusher, which isn't a death-defying act to drive around in a parking lot. So there's some other events with some not quite Battlebots level arenas where it's a lot safer to run Kraken and those kinds of robots. So maybe we shouldn't build spinners. Be more fun.
So a great question from the chat. You can been wondering, Matt in the chat asking, you engineer failure points, things that can shear off on purpose or anything like that.
Yeah, Matt in the chat, shout out to Matt, asked if we engineer in any failure points, shear pins, purposefully delicate parts.
That's a good question. So for us, Andrea mentioned earlier about our molded wheels. So a lot of people, design their robots to be super robust, and which is kind of a lie, right? Like Will said, everything's kind of flexible, everything kind of gives a little bit. So our wheels are machined aluminum, 6061 aluminum, and they're pretty thin. Like the rim itself is probably 1/8 of an inch thick, and it's average nominal thickness, and they get hit a lot depending on who you're fighting. So we designed the wheels kind of weak so that they do get bent and they do take a hit and they don't rip off, because like Andrea said, we've had that issue in the past. So that's one failure mode that we kind of let happen. And then they can be out of round, they can be bent, they can be deformed, but they still roll. As long as they still roll, they're still functional. So the axles that we use now are 1-inch titanium, which have been great so far. Lately we've used them for 2 or 3 seasons or something like that. And they can bend without breaking, because we did have that issue also once before. So you kind of learn every season. You learn what fails and how it fails, and you iterate for the next year, and you come back hopefully better. So inside we also have, so actually this is a great example also. Hypershock uses a chain for his weapon drive, and we use V-belts, because while you have a slip clutch or had a slip clutch, to allow some slippage, we rely on our V-belts to transfer the torque from the weapon motor to the weapon, and it slips, sure. And we don't run our belts really tight because we want it to slip so that all that shock doesn't go back into the motor when you hit an opponent. So, there's definitely places you can do failure points, purposeful failure points. I'm sure you guys you talk about your wheels too.
Yeah, our wheels we also treat as sacrificial, but I'm okay with them getting ripped off. In fact, I want them to be ripped off. I'd much rather have a tire ripped off than the wheel jam, because we've learned the hard way that we can move around pretty well with one moving wheel. Even if, for example, in the match we watched before we got into YouTube Live, it was us against Lockjaw this year. The front 2 tires, gone. They're done. Wobbling all over the place, and eventually we actually went in and hit our own tire. Got it out of the way. But we didn't need it. And I'd much rather have the drivetrain keep spinning and the chains not be a weak link on the drivetrain, and just have the tires disappear. For us and for our tactics, it's given us better results. And then the pretty armor parts, so up here, the yellow armor bits are the pretty bits. And we're treating them as 2 things. 1, they look cool, which is very important. And 2, they're separating the big damaging hits from the inner layer of armor, which is the big heavy duty stuff. And I'd rather have the side of this or the top get crumbled in and nothing gets into the robot, and have to replace the pretty bits. Besides, they sell better on eBay that way.
So there's some good questions in the chat, and I actually want to change gears a little bit and ask more of kind of like a experience type question, because you even hinted on the wheels a second ago, and something you mentioned to us last night that struck me is the following for this is so crazy. You guys end up selling some parts on eBay, right? So we talked a lot about the design process and using SOLIDWORKS and all of that. Could you talk a little bit about what the experience is like almost building a fan base and getting recognition and being like, you know, Battlebots famous, you know, to an extent? I think everybody would love to hear that.
Okay. So, I mean, this is true for all of us, for most of the builders on Battlebots. First and foremost, we're Battlebots fans. We're fans of the show. When we showed up in 2015 for the first time on the TV show, our first fight was against Bronco, which is one of the coolest robots, one of my favorite robots, and to be in the arena at the same, you know, get to fight those kind of robots. You know, you talked, Will, on the show about having a similar moment fighting Lockjaw this season and Donald Hudson. So that's really, really cool for us. The show started in 2015, but BattleBots and BattleBots IQ, which was the collegiate version, was around much, much longer. I competed fighting robots that were a little bit smaller than this, 120 pounds. Back in 2004 was the first year I competed. I was in high school. I think Will started when he was in middle school.
I was 12. It was a cow-themed robot. It was made out of a 14-inch walk. It was upside down and had screws out the sides, and it was duct taped in black and white duct tape to look like a cow. It was awful.
Legendary. Yeah.
Yeah. Yeah, my first robot was called Kerminator. It was Terminator and Kermit the Frog for some reason, and it had a saw blade tongue that fell off first match, first hit. But it was enough to get us hooked. And my point in going on this whole Longabout story is that we've been doing this for a long time before it was on TV. So to all of, you know, this is like this underground hobby. My parents don't understand what I'm doing every day after school. Why I come with burn holes in my Catholic school skirt because I keep welding the robot in my uniform. You know, but now we get to fight on an international stage in front of, I don't know, millions of people and kind of share this passion with them, and it's no longer something that nobody understands. You go in any room and you ask if people have seen BattleBots, and somebody has seen BattleBots, so that's been a really, really cool transformation for us.
What's not allowed? Aside from entanglement, what's not allowed? Yeah, guns. Guns, tasers, as my wife initially asked, a bucket of acid. It's a pretty solid design, not gonna lie. There's some basic things, but for the most part, they try to let in as much as they think will be interesting. There's one robot that has a cannon. There's some limitations because it has to be safe, so there's it's a bit of a mixed bag because it has to be safe enough to not damage the arena. So can it really damage another robot? Turns out it can. But they only get like 1 or 2 shots. That's double jeopardy. There's limits on tip speeds. That's mostly safety related. You can have an engine, Ice Wave. Mark DeVitz, another SolidWorks team. He's got an engine in the robot and spins up a bar. It sounds terrifying and it's fantastic. Yeah, no electrocution, no EMPs.
If it sounds too good to be true, it probably is. If it sounds too good to be true, it probably is. Like Will was saying, you know, safety is a big concern to the arena because underneath the arena floor, there's all electrical cables and stuff for all the audio, video, and there's electrical running like everywhere. So, you know, there's a lot to be considered as far as like what would be an EMP. Obviously, would blow out all the video and audio stuff, and the show would be over. So they wouldn't allow that. You know, so stuff like that. If it sounds too good to be true, it probably is out loud.
Awesome. There's so many great questions in the chat here. Let's pick another one here from the YouTube chat. I think this question's probably on everybody's mind. How much does it cost to build one of these robots? We heard a little bit about like the weight and requirements. How much does it cost?
Wow, what a spectrum. Okay, how much does a robot cost? Let's start with the preface that not all robots are created equal. Some people have much better financial responsibility than I do. Do you want to say the number? There's a range. Jackpot 2020 showed up and they were saying it was what, $6,000 to compete. their whole season, everything. Admittedly, they were relatively local. They were within driving distance of the competition, so they saved on some airfare and things like that. But it was like $6,000 to compete. And then there are robots that are $60, $70, $80, $100,000 a year total budget. You know, one robot going into a match, one Hypershock is somewhere between $20,000 and $25,000. That's what it costs. And I don't like to look at that spreadsheet. It hurts. But that's where it's at. And like Mike said in their presentation, the level of competitiveness has gotten so high. We used to show up with one robot and a couple spares and we were good to go. Now all the series competitors show up with at least 2 robots. We had 2.5 worth of parts, and we ordered a new chassis while we were there. We showed up with 16 tires, and we made 16 more tires while we were there. That's just what it takes to compete now.
Thank God for sponsors.
Yeah, I was going to say, so with robots costing that much, that means this is your primary job, right?
With robots costing that much, surely this is your primary job. No. No, this is a passion project. As long as it's fun, we will keep doing it, but it is not a money-making endeavor. This is very much a money-spending endeavor. So yeah, thank you, sponsors. Oh, and merch. Merch sales help. Merch sales and eBay sales. The show itself does not pay us much. We have some travel stipends and some things like that, and there's a little bit of prize money for winning, especially if you do better. But it doesn't cover the whole thing. So we're looking for sponsors. We're trying to be frugal where possible. Some people better than others, and merch and personal money and obsession.
Some great questions in the chat about the different configurations, the different versions of the robot. I think that's something that both teams kind of highlighted today was the use of configurations, changing out weapons, changing out pieces of the design. Do you find any one design the most common, like one you keep prefer, like it's your go-to? Could be for either team. And a add-on to that, folks also want to know, do you reuse parts? Is there any parts that live on and go forward to the next season?
Hypershock has 2 primary configurations. One is, neither of which are shown on the robot currently. When we go to live events, we think it's fun to show configs that we couldn't or wouldn't run in a match. So usually when we're running the single disc configuration, we're running it with a large wedge. The single disc is actually constructed out of 3 separate pieces of steel. So in the middle, you have a piece of inch-thick S7 tool steel, which is hardened to 57 Rockwell. It's substantially harder than most of the armor in the rest of the field. It is sandwiched between 2 pieces of AR-500. The reason it's sandwiched like that is if we're fighting a big horizontal spinner and that comes across, we don't want it to hit the relatively brittle piece of S7. So the relatively soft piece of AR absorbs that impact. We're running with the wedge. The wedge is designed to kind of deflect things up and then back out. There's little wings that hang out over the top of the surface. The other configuration that we run is the dual disc configuration. So that's 2 1.25" S7 tool steel discs with a hub between them. The hub is magnesium to save weight, improve the MOI efficiency, and then we run the forks that you see on the robot currently. So the reason that we both kind of like that double disc is that it gives us a wider, effective attacking angle. So instead of having, look at the single disc, it's a 2-inch thick weapon. That's it. That's all we have to hit people with. When we have the 2 discs, we effectively have a 5-6 inch wide weapon. So that gives us that much more of an angle of attack. We can be that much more imprecise in how we're going after people.
So some of the parts that get reused year after year, it really varies year from year. For us, I think the electronics are probably the most, one of the more expensive parts, one that we aren't sponsored, so we don't get those parts. It costs quite a bit. So anything that's salvageable at the end of the season, we try to reuse. Motors, usually we don't wind up with any left at the end, so we wind up buying more. Pretty much the entire robot is rebuilt. I don't think we actually reused any parts of the actual robot from last year, sadly. Maybe some hardware we had left over or something like that, but you know, like if you have a premature failure of a piece of critical hardware, or you use like bearings are a great example. You know, you use them in these like loading conditions that, like I said, you know, is crazy amount of force on the weapon assembly and the titanium shafts and all that, that if you make it through the whole season, you know, you check it for damage, but do you really want to risk losing like matches the next year for, you know, a couple $100 in bearings or whatever? So at some point it's you just kind of swap parts out, preventative maintenance, you know, I think actually to Kyle's point about the weapon assembly, I'll let you talk about it because you did reuse that disc from last year, right?
Yeah, so another reason why we have that sandwich is because, surprise, it was last minute, and we had the 1-inch discs already, and Sen could cut half-inch AR discs. So we were trying to come up with a way to hit the weight target we were at with parts from last year. So the 2 aluminum hubs on either side, the yellow powder-coated bits, those we had, and we had been using a 1.5-inch wide disc, and we went to 2-inch overall, so it was a little bit heavier, a little bit more MOI, a little bit more durable, and then the sandwich turned out to be a great solution for it. But yeah, so the dual disc was new this season, and it worked. It worked very well, and I'm definitely gonna basically use the same design again. But it doesn't last forever. We got, you know, maybe 2.5 matches on average out of a disc before the teeth start to get all gnarled over, and you know, they don't have a sharp edge anymore, and that's one of the things we like, is a nice sharp edge. So then you start swapping out new discs, and then, you know, someone comes in and nicks your hub, which is, for us, it's a $1,100 billet of magnesium, and we only had 2 of them. So there goes one of those eventually. And we were tearing these things down at the end of the season, and the bearings are loose now. So like Mike said, things take wear and tear, and going into next season, we know we need to have more, because yes, the design works and it meets our needs, but it doesn't have an infinite life cycle.
This is a really cool question from Matt, again in the chat. You talked a lot about your data, your testing is failure, right? Like parts that fail, you learn the weaknesses, redesign, and make changes. Is there any other type of data that you collect, onboard data, or any type of you know, technical things that you can download afterwards, anything like that? And if that's the secret sauce, that's also okay, and you can't talk about it, but you know, interesting.
It's so secret we don't even know we're doing it.
So during the kind of in-between period, so about this time last year, we set up kind of a worst-case scenario test rig for our motors. So we're using the same motors on weapon and drive, and we are switching from Hall effect sensors to encoders. The problem with Hall effect sensors is when your motor is not spinning, they give you a very imprecise reading on position. It's not really useful for that initial torque load that we're trying to get out of them. So we took one of our heavier weapon discs, which is about 21 pounds, put that on a 3D printed hub, and pressed that onto a motor. Mount that in a vise, and we spin it up backwards in the shop. So we're hiding behind cabinets with a camera zoomed in really close on a laptop sitting on a table next to it, and that's how we're doing data collection. So we could get about 3 spin-ups out of that before everything starts overheating, between the 3D printed mount and the fact that we're running a motor controller without heat sink on it. And so we're kind of figuring out what is the absolute worst case scenario, what is the worst conditions we can put everything in, and can we still make everything spin? And after 3 weeks of doing that, we figured out we really like encoders, and we ended up using them all season this year.
There are some teams that are much better about telemetry, like Ribot comes to mind. They have one guy who's sitting there with a screen, and he's just watching motor temps. He's watching speeds, he's watching voltages, and they are making, you know, tactical decisions based on that feedback. For us, it's never been something we've prioritized. It just felt like another thing going into your brain that you just weren't going to be able to handle.
Oh, sorry. When you can finish. I'm sorry.
We're not smart enough.
That's the real answer. You know, I mean, everything you put into the robot, like, so we all use pretty much off-the-shelf controllers for motors, modified, whatever. But they don't have data logging capability on board. So you can hook up a USB to it and read it live, but you can't really record onto the controllers. So especially, you know, ours are pretty basic, so we don't have data logging capability. But so some people have, like Ribot, they have like another system that they plug in that intercepts all that data and transmits it back to their controllers. But you know, I'm of the mindset that that's just one more thing in the robot to break, and you have all these live wires, and you know, there's other transmission issues, and you know, you get one chance, you know, to fight these robots, possibly, and if you lose your first fight, you're out. Not in fight cards, but in the tournament. So the risk to reward ratio is just not there for me to do something complicated, and I'm not smart enough. So you know, that's the real answer.
And truth be told, okay, imagine you tell me that my left motor is getting really hot. I'm not going to slow down. There's another robot trying to kill me. I'm not slowing down. So it really doesn't change much for me.
This, you can keep this. The one kind of general question, I think you guys hit on this earlier, how much time is spent driving and practicing before?
The question is, how much time is spent driving and practicing? Not enough. Yeah, did I mention I built the thing on site?
Yeah, for us, so Battlebots ship date is a week before the filming-ish, roughly, 2 weeks. So we try to ship a functional robot. That's our goal. Oh, thank you, Will. So that's our goal, is to ship a functional robot. We don't often test the weapon. We actually never have tested the weapon physically hitting something before we've shipped until this year. We were able to do that safely. And so we get the robot driving as early as possible, which, you know, requires like the assembly and the wiring and everything. And we drive it around the parking lot, but we've been using the same motors for every season of Battlebots so far, for drive at least. So, you know, we have a pretty good idea of the mechanics of how it's going to drive, and we're not expecting really any surprises there. But we don't practice driving probably as often as people think we do. Or as often as we should.
Just one fun anecdote from what you, well, wasn't that fun, but from what you just said. This year in Witch Doctor, we changed the way we route the wires from the left side of the robot to the right side of the robot. They used to route through the back. And we decided, you know, in the back, you can get hit in the back. It's kind of dangerous, so let's move them. We actually moved them to right behind the weapon, which is the most protected place. And as Mike was saying, the very first time we test the weapon, we hit this weapon load. We just had all those connections, electrical tape. We just put a bunch of electrical tape on them. And when we hit the test load, the recoil to our robot was so hard that those wires slammed into the titanium top plates, cut through all the electrical tape, and created a short in the robot, and actually blew one of our $500 controllers. So we went, this was a few days before we shipped, so we were glad to have tested it because we actually designed and 3D printed and like basically a cover to put over our wires that could take more load than some electrical tape could. But that would have without a doubt happened our first match, and it's a super silly thing that, oh, we're moving the wires, they're gonna be safer here. We didn't think about the mass of the wires themselves during a hit. So testing is important, and you see robots have teething issues because they're doing really the real first testing during the show.
Great presentation. Two questions. What kinds of batteries do you guys use? First question. Second question is semi-related. Do you guys use any schematic tools at all to connect all that together?
So the question is what kind of batteries and battery chemistry do we use, and whether we use any schematics program to lay it out. For Witch Doctor, we use lithium polymer batteries or MaxAmps batteries. We are sponsored by MaxAmps, but that's not the only reason I'm saying this. They have a really high discharge rate, which we are running, you know, 5 motors at the same time on Witch Doctor, and I think like 600 amp draw if we are at full speed and full weapon. So that's not something that, you know, regular batteries can deliver without blowing up. We've definitely done testing where batteries are not happy and they get puffy just because of that current draw.
Yep, yeah, like most of the robots, lithium polymer batteries. I think we had 4 motors, all running 16S, so you know, north of 60 volts, and peak current limits were at 250 amps per motor. So in a terrible worst case scenario, we were drawing 1,000 amps instantaneously. No fires, no magic smoke, it's a double win. In terms of routing and schematics, I did a little bit in KiCad this year. I need to venture into SolidWorks, electrical. But we needed a little custom board for the magnetic encoders that Kyle was talking about, so I made a little thing there. The simplest little circuit. We try to be as simple as possible. One of the running gags of Battlebots is, well, they're not Battlebots. They're not robots. They're just RC cars on steroids. And that's because the things that make a robot, sensors and feedback and true, semi-autonomy or things like that, are so fickle, like Mike said. It's another thing to go wrong, and we never have time to really implement those things and take the time to develop those systems properly. So we end up with very expensive RC cars with relatively straightforward electronics. Yeah, that's the way it is.
Let's go for 2 more questions. Right at 8:30, we're going to wrap this up. We're going to get to our giveaways for those here in person, and then we'll say goodnight to our YouTube crowd as well. But let's take one more from the room. Anybody here in the room? Any other questions? Anything you're dying to know about BattleBots? I have like 10 questions in my head, of course. But anything else here in the room? Going once, going twice. Roy, over to Roy.
Sure. So off the top of my head, I believe the design guide is around 30-ish pages, and that's full of limitations. So if you're running pneumatics, you're only allowed to go up to a certain pressure unless you can justify to BattleBots that you need more pressure and that you can do it safely and that your robot can handle it without exploding. Same kind of rules go for hydraulics. If you're running any kind of fire, they have to test that. They have limits on how long it can be, how much gas you can carry, what kind of gas you can carry. For all of our batteries, we can only go up to, I think the limit before you need a waiver is 48 volts. They're talking about raising that to 60. They might raise the overall cap to 60. There were 2 teams this year running over 200 volt systems with the kind of motors you would see in an electric vehicle. So they're pulling crazy amounts of power, but at very low amps for that power trade-off. Beyond that, the whole robot has to operate consistently, safely. Yeah, so we talked about max weapon speed, so 250 mile an hour spinning tip speed. If your weapon doesn't complete circles, so if you have a hammer, there's technically no limit on that, but I don't think any of them are necessarily pushing faster than 250 yet.
It also has to fit through the door of the battle box, and some robots, it sounds silly, but some robots are really pushing that. We fought a robot called Mammoth this year that's taller than I am. It's huge. And huge is also another robot that they have to bring in sideways because it doesn't fit if you just go forward through the door. So there's some physical limitations, but it's mostly safety concerns. We have to keep the sport safe. So anything that can go through the polycarbonate walls is not allowed. So Will mentioned before there is a cannon design on BattleBots, but it's pretty restricted due to those concerns.
All right, so the last question here from the chat, and we're going to finish up with like a hardcore SolidWorks question. Let's bring it home with like, technical SolidWorks question. And I think when we were watching the sheet metal presentation, I was sitting next to Adam here actually, and like, man, I've never seen sheet metal designed like that, like a combination of sheet metal and surfacing and all that stuff all at once. It's very cool, very, very awesome. And to turn those parts around out of that timeline and get them done. And you sketch the bends on the parts, like that's pretty awesome that you did that. Did anything go wrong? Were any of the parts not correct? Did you have to readjust or deal with any issues there?
Oh, what was wrong? I think everything worked this time. It's rare. It's very rare, especially when you're doing things on such a time crunch. Like looking at the forks over here, we were looking at everyone's reveal pictures, because again, everyone's more responsible than me, and they already had the robots ready, and they already shipped them to Battlebots, and I'm still building the thing. So we could see everyone's pictures. And I see, oh, there's a lot of forks. I guess we should add some forks. So I think the Thursday night before filming, or that 19th over there, yeah, that one. On that day, I designed those forks. And we had them overnighted, and we couldn't even powder coat them in Miami. We had to find a new powder coater, bring our own powder to Vegas. Luckily, we found a local guy who was a champ. What a hero. And he ended up doing all sorts of stuff. But fortunately, everything worked in terms of fitment.
So for our sheet metal parts, I don't know if you guys are going to walk up and see the robots later or not, but where any time there's a bend line that intersects the outside perimeter, I usually put like a little tiny notch so you can just draw a straight line across the part where the bend lines are, just to kind of indicate, obviously we have a bend drawing that we give to the bending guy, but if he wants to trace those lines out, it's really obvious where they go. What?
But that's ugly.
You can't see it. Did you ever know I did that?
Well, now I do.
Yeah, exactly. So it's just a quick, reference. Like if someone measures, obviously, these robots are very organic in shape, and if you have a weird, funky bend line that's like 47.2 degrees off from the edge and some weird reference, you want to make sure that it's right. So last year, actually, things that go wrong. So we got our parts bent. They actually get bent up in Michigan, and the guy sent the parts down, and they were off by, not much. Maybe 1/8 of an inch where the holes are supposed to bolt in. And this was like right before we shipped. So rather than find someone local to fix it, we sent the parts back, overnighted the parts back to him, and he tweaked the bends a little bit and sent them back to us, and they fit perfectly the second time around. But this year everything fits perfect, so no problem. Because we added those bend gauges, so that was a really quick reference to make sure that the bends are the right angle since it's a funky compound bend.
I got lucky.
Well, I think with that, we were all very lucky to have you guys here tonight. So let's have a quick round of applause for the Battlebots teams. With that, we're going to say goodbye to the YouTube crowd. Stay tuned, YouTube, for some special announcements and an outro. Stay with us here in the room. We're going to hang out for just a few more minutes, and as Will mentioned, if you wanted to walk up or see the bots here in a moment, you'll have a chance. We're going to do some giveaways. So thanks, everybody. Thanks, everybody on the YouTube stream. Have a good one.
Hey, so if you like this episode of SOLIDWORKS Live and would like to see more episodes like it, make sure to hit the like button. It's the best way to let us know what you're thinking about the content we produce here at SOLIDWORKS. So this episode gave us a look at two great things, right? Good people and good robots. And before we go, we wanted to give a few shout outs on that note. So if you want to join a SOLIDWORKS user group or even start one of your own, your ideal starting point is SWUGN.org. This will give you a look at upcoming virtual and in-person meetings, as well as information on how you can start a group in your own area. And we definitely saw and heard about some good robots. So on that note, we're trying to make it easier than ever for anyone to get into making, whether that's robotics, woodworking, home DIY, or really anything else. And with that said, we wanted to give you guys a 20% off link as a thank you to our viewers to the 3D Experience SOLIDWORKS for Makers offer. And that includes 3D Experience SOLIDWORKS Professional, Delmia machining capabilities, offering 3-axis milling and wire EDM for all you Windows users, and 3D Creator and 3D Sculptor, so you can design anywhere on any device from a web browser. And thank you to Team Hypershock, Team Witch Doctor, the team at Rewatchable for producing this episode, SOLIDWORKS user group leaders Adam Abernathy and Roy Whitehead, as well as the SOLIDWORKS community and marketing teams for coming together to make this episode what it's been. And of course, thank you, right? Be sure to subscribe and hit the notification bell to keep up with all of our live streaming content here at SOLIDWORKS. So we'll be back on Friday with the next episode of SOLIDWORKS Live Design, when we'll hang out with Kirby Downing, SOLIDWORKS champion, who will show us how he designed and created a custom soundboard for use during his podcast. So you stay tuned, and we'll talk soon.